So in this part, we're going to make some examples of how to calculate with derivative with trigonometric functions. And we're going to apply certain properties that we'll learn before, like the product rule and the quotient rule. So first, we have this example here where we're going to take the derivative with respect to x of the function y equals e to the x times cosine x plus sine of x. So if y is that, then the derivative with respect to x is going to be a product. So it's going to be the derivative of e to the x times the function cosine of x plus sine of x without taking derivative, plus now e to the x alone by the derivative of cosine of x plus sine of x. So essentially we're using here the product rule. Now the derivative with respect to x of e to the x is just e to the x, and we're left with e to the x multiplied cosine plus sine. Now on this other side we have e to the x times the derivative of this. Now this is a sum, so we're going to use the derivative of the sum. Derivative of cosine is minus sine, and now derivative of sine is cosine. Notice that we have a lot of similarities here. We have sine e to the x and minus sine e to the x, so notice that this is going to get canceled with this. And so now this is going to get added with this part. So the end result is going to be 2 to the e to the x cosine of x. Now, in the following examples, we're going to use a couple different properties. So here we start with the subtraction rule. So solution. And for A, if y equals tangent of x minus sine of x, we're going to use that we know already what is the derivative of tangent of x. Since this was done in one of our previous examples, we get to do the derivative of tangent of x minus the derivative of sine of x using the subtraction rule or the sum rule, and this is just going to be secant square of x minus cosine of x. Okay, so that's the simple one. Now for B, we actually have to use quotient rule. Okay, so if y is cosecant of x over 1 over cosecant of x, we do have a quotient. And so y prime is going to be the derivative of cosecant times 1 plus cosecant of x minus cosecant of x times the derivative of 1 plus cosecant over 1 plus cosecant of x squared. Now, of course, in here, we're going to need to not only take the derivative, but also probably simplify it. So the derivative of cosecant is minus cotangent of x minus cosecant of x. So minus cotangent of x, cosecant of x. Now times 1 plus cosecant of x. And now the derivative of 1 minus cosecant of x is just going to be essentially the same thing. So we're going to have cosecant of x multiplying minus cotangent of x times cosecant of x. Notice that the derivative of 1 is 0. And so we don't have to add anything special in there. So now we're left with simplifying the last piece. Notice that if we just distribute this, we're going to get minus cotangent of x cosecant of x, and then we're going to get a minus here with this. So that's going to be minus cotangent of x cosecant x squared of x. And now from this one here, minus and minus is a plus, and we're going to get plus cotangent of x cosecant x squared of x. Okay, So we're actually getting the same thing, plus or minus, and so we get to cancel this part. So the end result is going to be minus cotangent of x, cosecant of x, divided 1 plus cosecant of x squared. Okay. Now let's see what happens if we take higher order derivatives and how this is going to behave using trigonometric functions. So now we have the function f of x equals 4x squared plus times cosine of x plus ax sine of x. So we want to aim to take the second derivative. So for that, we're going to take the first one. So now let's go and do the two product rules that are in here. We're going to go directly to the derivative. Derivative of 4x squared is going to be ax cosine of x, and then plus 4x squared, and then the derivative of cosine of x, which is minus sine of x. Okay, then plus the derivative of ax, which is 8, a sine of x, plus ax cosine of x. That's just what we have here. Was that we applied to the two product rules. Now, in here, the best that we can do before following to the next derivative is to simplify. So we get 16x cosine of x from adding this and this, plus a sine of x, and then we're going to get minus 4x squared sine of x from this place. Now, thanks to that, and to simplifying, getting our second derivative is going to be a little bit more simple. This is still a product rule. So the first, the derivative of this is 16 times cosine of x plus 16x, and now the derivative of cosine, which is minus sine, plus now the derivative of a sine of x, which is going to be a cosine of x. And now we got to do the product rule of 4x squared sine of x, which is ax sine of x plus 4x squared cosine of x. And remember, this minus is multiplying the whole thing. So now we're almost done with this. We just need to simplify a little bit. So this is going to give me 16 cosine of x minus 16x sine of x plus a cosine of x. And then from here, I'm getting minus ax sine of x and minus 4x squared cosine of x. I gotta be really careful when folding this, making sure that I have common things. So for example, 16 and a cosine of x. I don't have anything else, so these are gonna fall together in 24 cosine of x. Also, minus 16 sine of x minus 8 sine of x, they can fall together as well. And they're gonna become minus 24x sine of x. And finally, we got minus 4x squared cosine of x. And that's the second derivative. As you can see, having a trigonometric function inside makes that the derivative just continuously flip around, and we almost always get something that is going to become larger, especially we have products and quotient rules. Last but not least, we can do the type of exercise when we find the equation of the tangent line. So in here, we want to find the equation of the tangent line to y equals cosine of x at the point x equals pi half. So for that, remember that we always have the function, and then we need to have a point in the slope. The point clearly is pi half, f of pi half, which, by the way, f of pi half here is just cosine of pi half, which is going to be 1. So we have the point pi half 1. And now we obtain the derivative. Of course, f prime of x is minus sine of x. And turns out that f prime of pi half is actually 0. Okay, so we're computing here, And now if we use the point slope, which is y minus y0 m x minus x0, we get that y minus 1 is equals 0, x minus pi half, which is going to yield y equals 1 as the equation of the tangent line at that point. So we have a constant line for this point in our tangent line. And that's all for this particular section.